Now the wedge product gives us a multiplication on the alternating tensor, and it can be easily checked that it's associative. Thus, it turns a space of alternating tensors into an algebra. But it's not a commutative algebra. It's instead what's so-called an anti-commutative graded algebra. So what's a graded algebra? Well, a graded algebra over some field K is an algebra that has a direct sum decomposition into components AI that's such that the multiplication map satisfying the following, it should take an element in AI and AJ into an element of AI plus J. Now, the space of alternating tensors is a graded algebra where the grading structure is given by, so these AI are just the I covariant alternating tensors. And the multiplication is the wedge product, because if we wedge an I tensor with a J tensor, we get an I plus J tensor. Now, this multiplication is anti-commutative, which means the following, that if F is an K tensor and G is an L tensor, then F wedge G is not going to be equal to G wedge F. They're going to be differ by a sign, so plus or minus G wedge F, and the sign is determined by this product of K and L. Thus, we see that under this wedge product, the alternating tensors form an algebra, actually an anti-commutative graded algebra called the exterior algebra of V. We'll denote this algebra by this. The grading structure on it is given as follows, where these now stands for the space of K alternating covariant tensor. Okay, so that's the definition of the exterior algebra. Next, let's talk basis.